Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Start this second session about the VENUS-C with two experiences, two real-world experiences that correspond to two scenarios that have been implemented in applications in different areas. The first one is called Drug Design Experiment in the Cloud that will be given by Simon Woodman from the Newcastle University, and with a work that demonstrates the use of workflows in this VENUS-C infrastructure for the specific problem of life science and the pharmaceutical industry. So please.
Thanks, Ignacio. Yes, so I'm Simon Woodman. I work at Newcastle University, and this is work that has been supervised by Paul Watson and done as a combination of myself, Hugo Hayden, who's here and is going to help me with a demo later on, and Jacek Kalla, who unfortunately isn't here today. So what we're going to talk about is our scenario within VENUS-C, which is to do with drug development. Now, my background is I'm a computer scientist. I'm not a drug developer, but we work with people at the Northern Institute for Cancer Research in Newcastle and also the pharmacology department in University of Sunderland. And so really the use case has been driven by those scientists. We've just been implementing it. So I'll talk through that scenario. I'll then go on to where we were before we started the VENUS-C project and give you sort of a bit of background about that. We'll then have a look at the architecture that we've implemented within VENUS-C. Then, assuming we've got time, I'll talk about a provenance capture system that we've built, which is of particular interest in the drug development scenario, and give a quick demo of that, and finally sort of mention a bit of future work. So the key question that our colleagues in chemistry want to answer is, what are the properties of a given molecule? For instance, how toxic is it? How soluble is it in blood? What sort of biological activity does it do? And so historically, the way to ascertain this was to perform experiments. However, performing experiments is sometimes necessary and ultimately necessary, but at the early stage, it's time-consuming, it's very expensive, and there may or may not be ethical constraints. And our little fluffy bunny at the bottom doesn't generally like it very much. So the alternative is to utilize a technique called QSAR, which is quantitative structure activity relationship, and it basically says what mathematical function in terms of solubility does this molecule possess. And there are different ways to quantify that molecule. It could be in terms of its the number of atoms in it, its shape, and there are 3,000 or more than 3,000 sort of recognised ways of describing this molecule, and we call those descriptors. So, assuming that we can calculate those descriptors, we need some base data to take. And for the purposes of these experiments, we've been using some open source databases, namely something called Kemble and Wombat. And the key thing in these databases, they all have some data in there that represents the chemical structure, usually in terms of something called SMILES, which is a textual representation of the compound. And they have some sort of value that's been measured in previous experiments that describes what that compound did with respect to certain properties. So QSAR's, it's basically sort of a regression exercise. First of all, we partition the training and test data from these databases, so we're going to be building models of it. We then calculate the various descriptors, and we don't use all 3,000, but we use sort of couple of hundred different ones. We then need to select which of those descriptors are suitable to build models from, and we're looking for things that aren't too correlated, otherwise they don't tend to build particularly good models. Then we build the models, and finally we add them to the database. Now, we automate this QSAR process, and one of the unique things about our particular use case is that there are multiple ways of performing each of these actions. So there are different ways you can partition the training and test data. There are lots of different descriptor calculators you can use, implemented in different languages, different licensing. There are different ways of picking which descriptors we're going to use, different algorithms to determine that. And finally, there are lots of different types of models that we can build. And so the type of workflow we start with looks a bit like a tree. So we start with one input data set at the top, and we then have different ways of partitioning it, and we do a sort of a brute force approach that we try each different way of partitioning it. Then for each of those, we calculate all the descriptors that are necessary. For each of those sets of descriptors, we correlate them and throw out the ones that are too correlated. And then finally, we build lots of models for each of the sets of descriptors. So imagine this tree structure where one data set at the top results in 40 to 50 models. So that's the sort of the abstract workflow that we have for dealing with this. So what did we have before we started with VENUS-C? Well, we were working with some people who had a legacy system for performing this operation called the Discovery Bus. And it was built on an Oracle database, and we changed it slightly so that the Oracle database, instead of feeding sort of local servers to do the computation, we created a proxy local server that actually shifted the work to Windows Azure. And we had a bunch of worker nodes in Azure that crunched the data, and then everything went back into the bus master, the main database. And that worked, but the problem we had was that it didn't scale in any way whatsoever. So if we look at this graph, this basically said how many models per minute the system was building. We tested it up to 90-odd worker nodes. So that's these things sort of over here, although they were all running in Azure. And we found that after about 40, we actually got worse performance. So although we had this illusion of infinite resource in the cloud, we couldn't make use of it. So that was our starting point in VENUS-C. We had something running within Azure, but we couldn't make use of the resources available. So within VENUS-C, we've taken the legacy system and we've updated it. So the first thing we did was we took away the discovery bus, although we kept the same sort of abstract workflows and we kept the same computation that was happening at each step. And we ported it onto something called eScience Central, which I'll discuss in a minute. We then we changed the level of granularity that the parallelism was happening at. So within the discovery bus, every single block in a workflow was being scheduled to run on a particular machine. And a lot of these blocks in the workflows were very quick to run. They were just performing a little bit of data manipulation. And obviously some of them were more computationally expensive, but there were a lot of very cheap blocks to run. And so we changed the unit of parallelism, so we now actually operate on a workflow level, and the whole of a workflow is assigned to a machine. So that means that the application is less chatty to and from the server. And I'll show you some results later on that we've actually got sort of quite a lot of speed up. So eScience Central, very briefly, is a platform for cloud-based data analysis. It has a notion of sort of data that's stored within it, which is versioned and secure, so it has sort of access rights built in. We can write workflows to process that data, and the components within the workflows can be written in either Jar, R, Octave, or JavaScript. And we'll see a demo of some of these workflows running later on that's doing some of the modeling. So within VENUS-C, we've taken this eScience Central system and we've deployed it into a virtual machine in Azure. And then we've deployed workflow engines into the generic worker. And our use case for generic worker is slightly strange or different to other people, certainly, because we deploy a workflow engine which is a very long-running task into the generic worker. We've got a prototype for CDMI for the data access, although that's in very early stages. And with regards to CompSS, running it on the Barcelona supercomputer, we've got a prototype implementation there. So this diagram looks similar but much more abstract to the ones that Gertz was showing earlier. But the idea is that we've got this virtual machine role in eScience Central which is able to submit jobs and manage workflows via a queue, and then into the generic worker we submit a job which is a workflow engine. That talks to the eScience Central server running in the virtual machine, and internally uses local storage to process the workflows, and the results are put into blob and table store. And so what we can do is we can have one virtual machine which is running the eScience Central server, and we can then scale these generic workers up and down depending on the load. And we found that this gives very, very good performance results. So this is a slightly different graph to last time. What it shows is as you add more nodes to the system, an ideal 100% speed up would be the green line there, and we're actually achieving about a 82% speed up. So as we've got 100 machines in the system, it's performing 80% as fast as it should theoretically. And in terms of a comparison with the original Discovery bus, this orange line is the same data set that we saw earlier of requests per minute, models built per minute, and the slightly lighter line is the new system. And so we can see that there's about a six-fold increase in the performance that we're seeing from this system.
What was the reason for that performance of Discovery bus?
So it was the way that it was doing the scheduling. So because it was very chatty, if you had a component that was very quick to operate within Azure, it was then sending data back, so there was a lot of data transfer, and then the coordination software had to figure out what needed to be done next, and then schedule that. And there was although each one didn't take particularly long, there were an awful lot of them. And so by having the level of parallelism of a workflow, there's a lot lower load on the server, because the workflow runs and then transfers the end results back. So within the VENUS-C project, we've seen this speed up, and use the generic worker has hopefully allowed us to be able to more easily port it across to other architectures as well. We haven't yet started looking at running it on Emotive Cloud directly, but I think there's a generic worker implementation in the pipeline that would allow us to do that. So the last section of the talk is going to be about provenance capture, and really why it's important within the drug development scenario, and how we do it, and we'll see a demo as well. So for drug development, it's important that we can capture both the data and the process. So we want to be able to answer questions such as, for a particular model, how was it generated, which algorithm was used, which sets of descriptors, and how reproducible are these results. Slightly more generically, we're looking at how bugs have manifested in the system. So if we find out a particular version of a service has a bug in it, which models have been affected by that bug, and can we regenerate those models using a newer version of the service, which is in theory bug-free. So within eScience Central, there are various different ways of accessing it. So there's a website, and there's an API, and then there's a separate API that the workflow engines use. And we need to be able to capture provenance for all of those aspects. So it has to be caught at the core of eScience Central. The way that we capture provenance, or the way that we store it, is in a graph database called Neo4j. The reason we do that is that sort of a provenance trace is inherently a graph structure, and so storing it in a database that is intended for graphs seems like a good idea. The graph database, instead of having a notion of tables and rows, it has notions of nodes, relationships between them, and instead of querying it, you traverse it. So we built some libraries for interacting with these based on the Open Provenance Model, and there's also a REST interface to it which allows us to perform some traversals. So very quickly, what does it look like? Well, for the same abstract workflow that we had before, if we've got a model that's been built, it's been built by a model builder workflow, and it used a descriptor file as input. And the structure of that workflow has an internal structure which is also represented as part of the graph. So you can see it's a directed graph. Now ours are a bit more complicated than that because these are some of the actual workflows we use. And what happens is the workflow at the top, it does some work, gets a set of results, and then schedules one of the middle workflows for every line in the results file. The same happens in the middle workflow where it does some work. I think this one's, I'm not sure what this one's actually doing. It does some work to manipulate the data, computes some functions, and then for each of the results of the output of those functions calls a number of the bottom level workflows. So we end up with this tree structure with links between all the workflows. And what we want to be able to do is, given a provenance trace, we want to be able to reconstruct one virtual workflow that spans multiple physical workflows. I've been given a 5-minute warning, so I'm sort of rushing a little bit. The way that we do that is that the top workflow up there imports a file, then it calls a service, then it exports it. This second workflow takes takes as its input the output of the previous workflow, and then does some more processing, and we end up with a result. First thing we do to construct a virtual workflow is we remove the various data items, because our workflows send data directly from one service to another. We end up with this middle one. And then because we want to join these together, we remove the export file and the import file and join them together, and we end up with this one virtual workflow here. I think I'm actually running a little bit short of time for a demo, but if anyone would like a demo, then please grab me. I'm here sort of for the rest of the week. So future work, sort of in terms of integration with the VENUS-C platform, we're looking at sort of migrating it to other providers and working more within the CompSS side of things. Improving CDMI and the traffic redundancy protocols that Ilya was talking about, because we don't have particularly large files, but we have a lot of little files, and there's a reasonable amount of duplication in there, so we think that the traffic redundancy elimination could actually give us some quite big benefits. And also looking at the integration with the accounting and audit services. From the provenance side of things, because we know how long the individual services within the workflow took to run, we're looking at building models of the workflow to predict future resource requirements, so that we can estimate ahead of time that in an hour we're going to need a whole bunch more generic workers brought up, and so we can bring those up ahead of time and also shut them down when there's less work. So that's it. Any questions?
Thank you. Any question for Sam?
I assume the move to Postgres was simply cost, not technical.
So the eScience Central system was already using Postgres, whereas the Discovery Bus was using Oracle. Yeah.
Any other question?
How generic
It's quite generic for other types of applications as long as they don't require integration with a human. So it's not particularly good at sort of a workflow where you require some human input halfway through.
Have you looked at other applications?
Yes, so we're working with people who are doing analysis of physical activity data. So they capture a lot of sort of XYZ acceleration over a 7-day period, and then they're using eScience Central for the analysis of that. There's various other sort of data files that we're getting in and doing analysis of.
So using OR on eScience Central, the version of OR that you use, is that configurable or?
Yeah, so we have a notion of a library, and a service can depend on a particular library, which could have a different version of R in it. And what happens is at runtime, that particular version of R is downloaded onto the node that's running that workflow if it's not already present, and configured and then run. So within a particular workflow, you can have blocks that are implemented in different languages or require different versions of different languages.
Any other question? No? So we can thank Simon again and Joe for coming. So next talk will be given by Barzon. Furio is the director of Prefab, Prefab, which is a small startup that has been created on the area of aiding the complete cycle of manufacturing building to Prefab pieces. He was also the founder of Collaboratorio, another company that was with a similar aim, creating portals for assisting on the global process of building information. And the talk, the title of this talk will be a software platform for building industry.
Okay, so I'm so glad to be here with you today. I will bring to the discussion a different kind of perspective, the perspective of a small company entering a European research project, dealing with it, and coming out with a new spin-off company. The partner company in VENUS-C is Collaboratorio, sort of micro-incubator for digital innovation in the field of architecture. Green Prefab is the spin-off coming out for this project. I will talk about the spin-off with this business perspective. So green buildings. Green buildings is a new emerging market in the world. The building industry is leading about 15 to 20% of the whole market of every kind of products. The green building market is a subset, is about 1 to 2% of the whole building industry. And it is very different in size from different kind of architecture, different materials, different size of the building, and different for standards in local applications. But basically in literature, green building is a building that has received a certain certification from institutes that deliver those kind of certificates. Those are the certifications we have so far in Italy, and it's not a particular case. It's at the moment a complex panorama of certification in the world. So the market it's about 400 billion in 2015. This is the prevision from the global industry analysts made in 2010. And it is a market enlarging of more than 5% a year. And this is the market where this platform want to enter in. The more promising markets are first place, first level China, second US, third Europe. When I say Europe, I mean Northern Europe specifically. Those in the pictures are all the meetings we have done face to face, and you can see the intensity of the meeting in China as the more promising market. Consider that the World Bank say that in 2015, half of the of the all building construction size will be in China. So the size of the market in China is big, but also their needs for green buildings and their capacity to industrialize the process. Because what I'm presenting is a way to industrialize the building process. In fact, our main advisor is Professor Qin Guo from the Tsinghua University, and he stated out with the real problem in green buildings. So we can achieve green buildings, but at the end of the day, they will be very, very expensive to be realized. So green prefab enable a network to achieve a low-cost green buildings. So this is the basic model that stayed under our solution. It means we are transferring technologies, processes, materials from other industrial domains, automotive especially, the field, and also aerospace, into the building industry. So let all the stakeholders sharing in real-time information during the different phases we have to build a building. And basing this production on an industrial way, that is the prefabrication model. It means creating components, prefabricated components off-site into the factories. So a very short video that will introduce you more on this system. I give you background about the building industry. So nowadays we are exploring the prefabricated market, and we are integrating already existing commercial products into a new digital platform. So we are digitalizing products with their 3D geometries, and we attach information to each component into our database. Where we provide information about the structural behavior, about the eco behavior of the components, and so on. And we do that for different products, and we add and integrate them into our platform. It's an open platform where we can add multiple products within. At the end, we have a library already running with geometries, 3D, and information attached to them. So that the Lego system that we provide through our system to architects that stay somewhere in the global villas, in their offices, and with those 3D models, they create their architectural concepts using their own software. At the end, they will deliver to the system a whole 3D building, 3D virtual building, that will be available to the next player, that in this case are engineers already waiting into the platform, and they will receive 3D models with precise geometries connected to production with the information they need. If they are structural engineers, they already have data where they can achieve their tests easily, and giving a feedback also in a speed way. At the end of the process, the real estate, or in the private case, can decide that all the performances are okay. So also the purchase order are directly derived from the 3D model, where we know how many parts of certain kind we have, of another, and the production can start negotiating times and prices again at that point. Complex logistic phase managed by the system, and at the end, the construction site that start with a chrono program that we extrapolate from the 3D model, where we know when each prefabricated component has to arrive, before and after which other pieces, who is causing delay, for example, in the construction site. And at the end, we deliver to the environment and also to the market a building that had a great engineering phase, where we foreseen exactly costs and performances of the building in general. Building automation system, like black boxes in the airplanes, that the comparison, will control and monitor how you are using this building, connected to the 3D model, and giving you reaction and also smart suggestion on a better using of this building. So it's a complex platform. We are dealing with competencies and companies. We are dealing with different ICT infrastructure and tools and softwares. And we are also dealing with real objects that has to be attached one to the other. So database is the platform, the first phase of the platform. We see the concept engineering involving architects and engineers, production off-site into factories and on-site for assembling in construction site, and operation of the system. So this is a PLM for building industry, so a product lifecycle management system going through all the phases till the dismantling of the building. And we can compute all the advantages on this whole life of the building. During the period of the project, we were already studying since 2 years this kind of models and facing the first clients and stakeholders interested in that. During the project and with the boost of what we have done in VENUS-C, we decided to establish the company with my partner Renzo Taffarello and a board of advisors that is growing. Let me just mention Professor Vladimir Badzianak from the Department of Energy in US, one of the founders of Energy Plus, that is a software for eco-efficiency analysis, and also of IFC, that is the interoperable format for CAD for 3D models that we are using. Of course, we have also established a relationship in VENUS-C with Microsoft Research, and in Progetto Manufattura, you will see later that they are providing us the first pilot cases to be built. We are coming out from European research projects. That were the money that we used to develop so far this system. One was about database, ontology, and semantic relations between data in the specific domain of architecture, MACE, metadata for architectural context, led by Fraunhofer Institute. And then VENUS-C, where we are implementing cloud computing for the engineering phase. So cloud computing is required by engineers within our system. Those are the three first modules we are developing. We entered the project for the rendering engine. So we needed to visualize simply our project with a single picture, with movies, or with immersive real-time environments. And it takes a lot of time to do those kind of simulations. So we entered with this scenario. It happens that another partner from Valencia, University of Valencia, were leading the scenario on structural analysis, and a pilot case from the open call, you have seen in the presentation, we had an open call involving 15 new small scenarios, proposed a building energy simulation. So what we are doing is packing it on a single platform for delivering a full service for engineers. So this is about our rendering engine. From our platform, architects download 3D building components. They import in different CAD software. Maybe you have mentioned, you know about BIM, Building Information Modeling, Revit, ArchiCAD, Allplan, MicroStation. We deliver the Lego system in all those formats. But if you have SketchUp that is for free, you can use it. And then you turn back the model to the system, and we use LuxRender for creating the rendering. LuxRender was selected because it was open source, so compiled also in a way that we can understand how it worked. It was the first software we ported into the cloud. At the end, it is now running in two versions. One is related to Microsoft Windows Azure infrastructure and services. So it's already running. The first public release to a community we own in Italy that is about 20,000 architects, a subset of them, of course. We will start using this application for rendering visualization. I will not go inside this architecture, but we basically use a web role where people upload their files. But I will show you the video on how it works. So this is the Green Prefab demo platform available online. You enter with your own credentials, so you say where you want to create that project and which is your group. And you start downloading from the 3D library the products you prefer and you need to have for your project that are also parametrical, so they can change in size and in form, also even in finishers and in materials. They import into their software, in this case within SketchUp, and where they have a control of the architectural shape and basic information about materials. They don't have all the information for engineer here. They upload the system. They upload the components into the system. It will provide some files and some forms where they can select different size of the final image, the quality, the time of rendering. And this is the first application that it is running so far in Windows Azure. At the end, it will, let me skip a little bit. At the end, it will provide a result page where the architects have their own picture they are waiting with the rendered materials and lights. But the same infrastructure has been developed also with the Barcelona supercomputer. Comp Superscalar is an infrastructure they have in Barcelona, and it was not a problem to involve a similar model of production, even based on Lux Render for this kind of infrastructure, even using GPU clusters. The other partner we are integrating into the Green Prefab is developing Architrave, that is a software for structural analysis, and they are developing within VENUS-C the application on Windows Azure, and then will be easily connecting to this kind of platform. Wow.
They agree.
Finally, this is the most recent application, that is the eco-efficiency analysis we are integrating. Also, the most data-intensive application. It comes out from a pilot from the Royal Danish Academy in Copenhagen, and it is attracting a lot of interest around it for Energy Plus, and also a specialized and customized version of this Energy Plus called JE Plus. Consider for this kind of application, for one building nowadays, they have to test it for eco-efficiency analysis, means energy savings and compliance for different certification models and protocols. They are running different tests, changing the facade, the window facade, changing the position of the building, and they are doing dozens of those tests nowadays. Dozens means about 2 days. 2 days of full computation on a 4-story building, for example. With this system, they want to test for the first time more than 10,000 tests using the cloud. So we will have a great mass of different options to automatically select the best solution in the building. Then Progetto Manifattura, I mentioned before, in Italy, is a new technopole that was established early this year, so it's very new. It's 9 hectares in dimension, and it is placed in Trentino province. That is an autonomous province in Italy. Autonomous means that 90% of the taxes stays into the province, and they have delivered services to their people and population with those money, also hospitals and schools. So an island within Italy. unfortunately, where happens that this technopole decided that green prefab can be of interest for them using the VENUS-CυγÇöFurio cloud application, the community we have of 2,000 architects in Italy, and involving Abitec, that is a district of about 200 companies they have already in place working for sustainable products in building industry. They already, as a province, so as a local government, decided to use Green Building Council, an institute that is there in Italy, that providing the LEED certification. You maybe know, because it's not only the most diffused in America, but in the world, in US, but in the world, and other kind of certification that they locally decide to implement. On the other side, there is the academic part that is CNR, IVALSA, that is delivering the technology the province intends to support and to use in their local region. That is a technology made by Wood called CrossLam, a specific structural component you can use for walls and for all the parts, structural parts of the building. And those are the first tests we have been working in the last 2 years, and these are in different places in the world, different in sizes. The pilot case in Trentino will give us the first real building that will be built in Italy in this case, and we are eager to have one full developed building within this system.
What do you mean by panels?
Prefabricated component, prefabricated panels. This morning from Fab, I've seen an interesting picture about data centers that were perfectly compliant with this kind of idea. So I hope in the future to add here some testing about those buildings. Very short unveiling about the business model that will be that let us to deliver this platform for free for different stakeholders, and instead we will have negotiation about 3% of each transaction that will happen within this system, basically purchase orders to prefabricators with industrial suppliers and real estates. And then, of course, there is training, and there are customized versions and a lot of other small business.
So out of the various actors, you will charge, the rich guys, so the real estates and the industrial suppliers.
Exactly.
And everybody else get free and contribute to the ecosystem.
Exactly. The prototype. The first approach. Then we will see. The prototype is online. If you have to have a look, go to greenprefab.com and enjoy the platform. That's all. There are a lot of advantages, different from each of the players I have showed to you. The biggest advantage is that is also creating this business model is for those guys, for real estates, or even public entities that has to create to build social housing. The main advantage of this kind of system is that you can control costs, you can control performances, and you can control costs with that. My father is a local builder contractor working the traditional way in the north of Italy. When traditional way means 80% of the market in the world, not only in our small village. With that traditional system, when you start a building, you cannot foresee exactly how much will it cost at the end. You will when I go to Blanquer, that is the biggest real estate in China, and I say that probably they have about 10% of unexpected costs at the end. They say that 10% is okay, sometimes it's not enough, it is more. So with this system, we can control the cost because we're working with an industrial model, and we can save those 10%, and that's a big result. At the same time, we can control the other performances for eco-efficiency, for energy saving, for example. So that's the advantage. Also, with we can speed up time with the kind of production that is prefabrication, and with the technologies we use, and with the network we are enabled, and the platform let's share people. Specifically for cloud, the advantage is time, with time. Because now for the different analysis they took, if they want to make 10,000 experiments, they will last for 1 month now. They cannot do it. They will be able to do in 1-2 days.
Yeah, so in fact, I think you already given the answer, because I wanted to understand without a commercial cloud infrastructure, what have you done? Running that on a cluster, running that on your own laptop, and well, in a way you're already anticipating that you would have taken 1 month. Where? On a laptop? On a cluster?
Yeah. On a cluster. On a cluster.
On a typical cluster that you have access will be 1 month.
Yeah. Yes. And on a laptop, you have to go test by test. You make one test, then you create a new set of data, and you make the second test manually. We are still in this phase. So what I'm saying with this, with my contribution, is that building industry is in a revolution period, and is really in need of new ICT tools and platform, aggregating new open networks within. So there is really a huge work to do on this domain.
So any other questions? No?
Thank you.